In this video, we're going to go the opposite direction, and we are going to draw the ionic compound from the name. So here we're just going backwards. So for example, if we had magnesium sulfide, I could look at my periodic table and know that magnesium is in the +2 state and that sulfide is in the -2 state to get to that noble gas configuration. And so the formula for this is a 1-to-1 ratio, so I just write Mgs. So Mg, the symbol for magnesium, and sulfide would be my sulfur with a 2 negative charge. I could look at sodium oxide. Now I know that sodium is a +1 oxidation state because it's on the group 1 metals, and then the oxide would be a -2 oxidation state. To get over to that noble gas configuration, it would gain 2 electrons. So I must have 2 of the sodiums to balance out that charge. So sodium oxide would be Na2O. If we take a look at one of those metals that can have more than one oxidation state, let's look at copper. So copper 1 oxide. Again, we know that the oxide is -2, and copper 1 tells me that it's in the +1 oxidation state. So this is going to be another example where, to balance it out, I'm going to have 2 coppers. So this will be Cu2O, copper 1 oxide. In order to balance charge, I need 2 +1 coppers and 1 2- oxygen. And now let's look at an example with a polyatomic ion. So aluminum is one of those metals that tends to have the same oxidation state all of the time, and that is Al3+. Nitrate is going to be your polyatomic ion, and the nitrate ion is NO3-. So in order to balance that out, I'm going to need 3 of those nitrates. So this is going to be aluminum, and then when it's a polyatomic ion, I put it in parentheses like that, and then a 3 around that. So there are 3 nitrates for every 1 aluminum.